Welcome to episode 4 of writing a 6502 assembler in assembly language. The goal today is to take the files specified on the command line argument, to open them, read from them, and then close them. And if you remember, the way we have it set up is I have a subroutine called getCL, which builds this data structure. It gives us an arg count, which has the number of pointers in the argv vector, and each of these pointers points to a string in memory, a null terminated string, which is the name of the source file. So what I want my assembler to do, because I don't have a linker right now, is it will just read each of these and basically concatenate them all together. So it will read this in pass one, it will read this, go through this file in pass one, it will close it, open this one, go through, close it, open this one, go through, close it. Then for pass two, we'll go back and open this file again, read it for pass two, close it, open this file, read it for pass two, close it, open this file, read it for pass two, close it, and so on. So logically, all of these will be one giant source file as far as the assembler is concerned. And that's really just because I don't have a linker right now, and otherwise I won't be able to take separately assembled source files and combine them into one. So for the moment, they'll just all be concatenated together. And actually that works quite well, as long as it's not an issue of wanting to keep some sort of object file around that you can, like a library that you can link to lots of different stuff. If your source is self-contained, this will be just fine. But anyway, that's what we'll do for the beginning. So now let's go look at the code. So here we are, back where we left off. The first thing I want to do is that when I read these files, I want to read them I want to read from the file one block at a time. That is 512 bytes of data from each file at a time. The assembler itself will look at the source code one character at a time, but I don't want to try to read one character at a time from the file. That would be really slow and wasteful to make a call out to ProDOS or your operating system, your disk operating system, for every byte. So I will read in 512 bytes at a time from the file and then get those out one at a time from the buffer. So one thing I'm going to have to do here is go back to this file that we worked on last time and go to the end of it, and here this myBuff is the place where I would read the data from the file into this space here. And if you remember correctly, this had to be aligned at a 256 byte boundary, and it had to be not part of the binary image of our assembler because of the limitations of how ProDOS on the Apple II does these things. I'm just going to change the name of this to, instead of myBuff, I'm going to just change it to inBuff, because this is our input buffer. It is where the file, the data from our input files will go. All right, so I'll just save that, and then we'll go back to AS0. All right, right now this is jumping to test, and test is the part that tests the file IO stuff. We don't need to do that anymore. Okay, so this is going to go away. And last time we also made it so that this whole thing of getting the command line is, it's like a subroutine we can call. So yeah, pretty much the first thing that has to happen when we start the program is we're going to have to call that subroutine. Okay, so we're going to call this subroutine that gets the command line. That's going to give us this thing here that creates this data structure here that we're going to use. All right, let me just check what's going on here. Okay. Right, this also gives us our ability to print stuff on the screen, which is fine. Okay, so let's go up here. So at this point, after this call to get CL, we have the command line in this structure. Well, at least if everything goes well. So what we will want to do after that is go through and start opening the files. And I think what I'm going to do is I'm going to get the address of this argv here. Whoops. Okay, so I'm going to get this address and just store it somewhere. I'll store it in a place called arg pointer. This is my usual technique of using self-modifying code. There are options. We don't have to use self-modifying code. With the 6502, we can put a pointer in the 0 page and then use the addressing mode that would look like this. My pointer y, right, with a put some appropriate value to y, 0, 1, or whatever, and we can access pointers like this. And there's nothing wrong with that. It's maybe in some sense better because we don't use self-modifying code, but 0 page locations are kind of at a premium because ProDOS uses 0 page locations. The Orca command line environment uses 0 page locations, and you know, I'm just not going to try to grab 0 page locations and use them and hold on to them. So when I need one, I will save it on the stack and then use it and then restore the previous value. And so I'm just going to use my self-modifying technique for the moment. Okay, so what I've done now is I'm going to put this pointer to argv there. Okay, and this, what I have to do is I have to open the file. And how is it now? I have to remember how it is that I open a file. It's a JSR open, and then I have here basically a pointer to the file name, kind of like that. And that's all I have to do to open a file. So let's just call this F pointer for a moment. So I will do okay, load this and then store this in F pointer plus 1. Okay, increment X. All right, so what's going on here is I'm going to start with the address of argv. I'm going to put that here. That needs to be a 1. And this can be that like that also. Okay, I'm going to start with the address of argv. So that's going to be, in other words, the address of the first pointer. Argv is an array or vector of pointers of addresses. So this is an address of an address, right? This thing right here. I'm going to put that here. And then what I'll do is I'll take one of the bytes at that address, which itself is the address of my file name. Okay, and I'll get the high byte first, and I'll store that here. And then I'll get the decrement X and get the low byte next and store that here. Okay, okay, I was just messed up. That has to be like that, sorry. This is load here, store here. So load from my arg vector and store here. High byte first, that's why this is 1, and then decrement X, it will be 0 but not negative, so I'll go back up here and get the low byte and put it in there. All right, now I don't actually have a pointer there, so I just make it 2 bytes of space that can be filled in with this thing. Okay, so there I'll open the file. Okay, and when I open the file, I need to check to see if it was successfully opened. If it did, if it successfully opened, the carry is clear. So I'll go there to, let's just say open OK. Yeah, it's just such a pain to think of all these names. So I think what I'm going to do here is I'm going to put here, this is main, okay. I'm going to call this, just call it main 0. All right, main 0. All right, and this is where it has succeeded. So I will store this in my file descriptor. This is just going to be 1 byte where I will store this data. And for the time being, it can just be 1 byte here. Okay. So that stuff below there is the get command line routine. So I'm going to store my file descriptor here in this byte. And then at some point, I'm going to load the file descriptor back up. And I'm going to JSR close to close the file because I'm done with it. And then what I'll do at this point is I will decrement argc. Okay. And as long as it's not 0, I'm going to go back up here. Well, if it's not 0, I need to increment this. I need to increment this thing here. Okay. So actually, before I do that, I will first clear carry, load arg pointer +1. That's the low byte here. And I will add 2 because I'm trying to get past, basically it's now pointing at this location. I want it to point at this location, which is 2 bytes further along. And store that in arg pointer +1. And then the high byte is an arg pointer +2. Okay, arg pointer +0 is this opcode here. Arg pointer +1 is the low byte of this, and arg pointer +2 is the high byte of this. And add a 0 to it, and that's just to handle any carry that might happen. Okay, so I've advanced this pointer here, right here, this address, to point at the next thing here. All right, and now after I've done that, I will go ahead and decrement argc, the arg count. And if it is not 0, then there are more arguments to look more files to open, right? So actually, I will make this main 0, which means this will be main 1. Yeah, this is kind of annoying, I know. All right, and now we'll go back up to main 0. All right, branch to main 0. And if argc is 0, then we're all done. We're going to return and exit the program. Our assembler is finished at this point. Okay. So what we have here is we're getting the arguments into argc and argv. We're putting the address of the beginning of argv here. Then this code right here copies the element of argv that we're pointing at here. It then calls opens the file. If it succeeds, it goes down here and stores the file descriptor. And then stuff happens, right? Like we would read and actually process the file. Then we're all done with that. We load the file descriptor and close it. We advance this pointer right here by 2 so that we're pointing at the next element of argv. We decrement argc to count how many we've done so far. If argc is not 0, then we still have arguments to process, command line arguments to process, that is files to read. And we branch back up here to main 0. Otherwise, we're done. We finish right there, okay? Now, what happens if, like here, we try to open a file and we can't open the file? We fail at opening the file. But then what we're going to do is just print an error message and quit. Like if you can't open one of the files, that's it, you're done. Right? We're not going to try to process any other command line arguments. We'll just say, too bad, you can't open one of your source files that you specified, probably because you typed it wrong. And so we're just going to quit. But we'll quit with an error message, right? So for example, and by the way, we'll use this later on. Of course, there could be errors in the assembly process. The assembler could throw an error because you've typed the opcode wrong, or because a branch is not, you're trying to branch to an address which is too far away, or things like that. So this whole error message will be used for that as well. So I'm going to load error message and print it out. And then I will go ahead and print out the name of the file, right? That makes sense. And that is pointed to by this thing right here. So we just have to load x, arg pointer +1. That's the low byte of the address of the string, which has the file name in it. And we'll print that out. Okay. And then we will print out a little bit more of a message. I'm just going to call it FNF message, which is file not found message. These things could change in the future, but for now I'm going to leave it like this. All right, FNF message, and we're going to print that out. And we will just, after we've done that printing, we will exit. We're done. Right? Exit after error. So what we need is these messages. I need to make these messages right here. And I'll put those right here for now. Error. Whoops. Okay. And FNF message. I believe I can do this to get a quotation, a single quotation character in here. We'll see soon enough if it works. Okay, new line. And I'll even put a period at the end to be grammatically correct. Okay. So that all looks good. I mean, at least for now. Now, when we open the file, at this point, all we're doing is just closing it again. And right, I think what I'll do is just leave it that way for now. I mean, of course, I have to come back soon and try to read the file. But what I'll do is I'll go ahead and print the name of the file out if we successfully opened it. Okay, and then just go ahead and close it. So we'll try this here. And assemble. Okay. Oh, it's looking for that my buff, and we just changed that to be IO buff, which is why we can't find it, because I just changed it. All right, that looks like everything. Okay. Unresolved reference IO buff. I think let's just see. I called it in buff, not IO buff. That's just my own dumbness. All right. Yeah, that's right. There's a different IO buff there. Actually, yeah, it's good. IO buff is definitely not what I want here. This is in buff. Okay, and in buff, in buff. Okay. Okay, open and close. Yeah, maybe I don't need to search for it. I think probably this just has not been set up as an entry point. Yes, that's right. I didn't make these entry points, and they have to be entry points. So I'm just going to do this right down the line. Okay, create as an entry point. Unlink is an entry point. Open is an entry point. Close is an entry point. Read is an entry point. Write is an entry point. Seek is an entry point. All right, and that should be it. All right, now we've got something. Now I'm just going to catalog. I need to give it some files that it can read in. I guess I'll give it its own source files. Let's try that. So if I WSAS and I say AS0, AS9. All right, yeah, well, that doesn't look so good. I see. Well, one thing we're doing is in that get command line, we're actually still printing out that stuff, which we don't want to do anymore. Okay. So get CL. Okay, here's where we're scanning for the white space. We store it. We scan for the command line argument. This one, we're all done with that. NCL. Yeah, here's where we're going to print all that stuff out. That's just a really testing code there, right? And looks like this is unnecessary. Let me just comment it out for now. If it's necessary some later time, I'll deal with it then. So all of this stuff here, below here, is testing code. I mean, starting here, going down here is testing code. So we're just going to return. Of course, later I'm going to delete all this stuff when I am absolutely certain I don't need it anymore. But we're just going to return, and argc and argv should be correctly set here. So let's save that. I don't need to actually go back to a new file. That's incorrect. Okay, so now after we get CL, we shouldn't print that stuff out. Get the address of argv, which is right here. Store it here. All right. Now I think what I'm going to do, just as a debugging thing, I'll just call this PFN. I'll call this more. So I'm just going to skip over the close here. And at this point, I'll skip over the open PFN. So this is just to try to make sure that I'm getting the actual file names correctly, right? The way it should work is I'm getting the address of argv and putting it here, and then this code will take not the address of argv, but what's at that address, which is another address that is a pointer to a string, and it will store that here. Yeah, so take that and store it here. Oh, you know what? I'm done. This is the pointer to the string. I was trying to load in a pointer to a pointer. That's not cool. Well, no wonder it didn't work. F pointer is the pointer to the string. This thing right here. Okay. So anyway, I'll go ahead and try this now. This should probably work now that I've found that problem. So, but anyway, I'm going to skip the opening and closing for right now, just to, you know, sanity check myself. Once I've gotten the pointer to the string and I've stored it here in F pointer, I'm just going to jump to PFN, and PFN will print that out, and then it will jump to more, which will just advance to the next thing in argv, sorry, to the next thing. And assuming that that works correctly and I can print things out correctly, then it is 9. Okay, good. See, now it's printing out correctly. I can go ahead and get rid of this, right? And I can get rid of this. Good, and now we should actually open and close the files. Okay. Now, yeah, I think it's the same problem. It's printing out the wrong thing here. If there's an error, right? Yeah, it is. It's printing out. It should be printing out F pointer, just like we had before. F pointer. Should be printing this thing out, not this thing. That doesn't make any sense. This is the pointer to the string. It's going to print that out. Okay, now that shouldn't affect the fact that it wasn't opening the file correctly. I mean, if it can't open the file, it can't open the file. It's just printing out the wrong message. But let's just make sure that at least that's fixed. Again, if I could remember the name of my own source file, that would be nice. Okay, AS0, AS9. All right, it says AS0 can't open file. All right. And I'm going to change the error message a little bit right now. That's actually the least important thing to do at the moment, but I'm just picky that way, I guess. Okay. So what I actually want to do is this copy paste is annoying, but I guess it works. Right, so you can't open file, then print the file name. Maybe I'll take that out. Like that. We don't want that. New line there. Okay. Okay, so error can't open file AS0. There's an extra space in there, but nah, no big deal. Just get rid of this. All right, so that will fix the error message. But now the question is why? Why is it not able to open the file? Right? Okay, so we jump to open, we give it a pointer right after as the pointer to the file name. And let's save that and load in AS9 just to look at this and make sure. Right, and that's what it does. It's just JSR open. All right, and the address. That's it. Open address. Oh, we have to give it the IO buff. Aha. Whoa, this is crazy. I never noticed this. This is kind of lucky at work. This should not be, those should be the same. I mean, that's just test code. And I'm sure it was the case that IO buff, the high byte of IO buff 0 and IO buff 1 was the same, so it was actually loading the correct value, but just that should not be that way. Okay, when I open a file, I have to give it this IO buff. That's why it's failing, because I'm giving it a bad, of course, you know, now I feel stupid because I could have checked the error message, the error code that I got, but I didn't bother to do that. Actually, I didn't mean to do that. I meant to do this. Right, before I open, I have to actually give it the IO buff. I mean, it's not, I have to give it. It's one of the arguments to open. And we'll use, I have IO buff 0, IO buff 1, IO buff 2, IO buff 3. Those are defined in the, well, they may not be defined anyway. IO buff 0, IO buff 1. So that will be the IO buffer it will use for the open, for the file. Let's save that, and let's get back into AS9. All right, and these actually have to be global. They have to be visible. Right now, they're only visible in this segment called test, right? And this segment probably should not be called test. It should probably be called, I don't know, PDOS or something like that. ProDOS. Not that it matters, because at the moment, at least, I don't use this label anyway. But these things should be global, that is visible everywhere. At least these should here, because I'm requiring the person who calls open to provide this, right? I'm not managing that inside this code. So in that case, there's this assembler I'm using, the orc assembler, has a global equate like this. Let's see if this works. I'm not sure if it will, but if it does, then we'll be happy. Okay. It's AS0. Right. Okay, can't open. Okay, so now I'm in fact giving it this, I just made that same stupid mistake here. IO buff 0, IO buff 1. Okay, JSR open, and this is a pointer to the file name. Okay. What I ought to do here is I ought to print out like that. I ought to print out, of course, the error code, which is in the accumulator. Right here. I'll print out the error code, then the error message, and so on. And this should be the error code returned by the open call. This is error code 40, and if I remember correctly, that 40 is the error code for that the IO buffer is not a valid IO buffer. The buffer that I'm giving to the open call is not a good one. Okay, and so let's look here. Where's open? All right, come on. Oh, finally, open. Okay, error codes. 40, invalid. Oh, invalid path name syntax. Oh, you know what? Boy, am I a dumbass. Oh, boy, my dumbass. Of course, the command line arguments do not have a... They're null terminated Unix style strings, but ProDOS wants a string that has a length of the string as the first byte and then the following string. So that's a little ugly thing. We're going to have to somehow fix that up. So we'll have to write a little piece of code that will change the command line argument from a Unix style null terminated string to a string that has a length followed by the characters in the string. Okay? So I think what I'll just do is make another little thing here. I'll call it fixCL. Okay, and what it is going to do, let me just put a empty space here, a blank line. I need to basically count the number of characters in the string, and then I'm going to have to sort of move all the bytes down by one, which will get rid of the null. I mean, it will move all the bytes down, and then, which I have room for because there's a null byte at the end, so I can move all of the actual characters that make up the file name down one, and I'll be writing over the null byte at the end there, but then I will put the count at the beginning. Of course, I could go back and fix the code, the get CL code here, to generate these types of strings that have a length byte at the beginning first. And that actually is not a bad idea, except for the fact that I probably will allow command line switches, like, you know, that you can control the function of the assembler by putting command line switches in there, and I don't want to deal with those in terms of like a length byte followed by a string. So for now, I'll just go ahead and write a little piece of code that will change the Unix style string into the kind of Pascal style string that Protos is expecting. Or I'm changing a C string to a Pascal string, something like that. All right, so I think what I'll do is I'll start with x being 0, and I'll load, I'm going to have a pointer here, the first character from the string. Okay, if this is the null byte, then we will go to fixCL1. If it is not the null byte, then we'll increment x and branch back up to fixCL0, which will be right here. Okay, and when we enter fixCL, probably just the easiest thing to do right now is we'll load in the pointer to the string in x and y. And then call fixCL. So it will store that pointer here. So this will be a pointer to the string. And then it will start loading bytes or characters from the string and counting, right? So when this loop ends, x will be the length of the string. For example, if we happen to pass a null string here, where this pointer in x and y, and the pointer that gets put here is just pointing directly at a null byte, it'll load x to 0. It'll load the first character in the string, which is the null byte. It'll say it's equal to 0. So it'll go down here, and x will be 0, which is the length of the string. So at this point, x is the length of the string, right here at this label fixCL1. Okay. What I would like to do is remember that length of the string that's in x. So I'm going to move that value into y by moving first x to a and then a to y. Okay, And that will be pointing at the null byte. The y is indexing the null byte. So I can use y now to index this. Actually, I need to make it, Let me think about this for a moment. What I would like to do this is going to be like a little complicated thing. So I'm not putting x minus 1 in y. So put x into y, decrement y, so it's x minus 1. And I'm going to get that one, and then increment y. So I'm going to, for example, if the string is, I don't know, 4 characters long, x will be 4 at this point. It moves that to y, and then decrements y to 3. Then it gets the character 3 and then puts it in from position 3 and puts it in position 4. All right, and then decrement y. And this now, after we decrement y, where y is indexing the place where we just took this character from. And 0 is the first place we would want to take it from. So if this y becomes 0 here and we load the character in position 0, we put it in position 1, we decrement back to 0, in that case, we're going to be done. So if it's not 0, we'll go to fix CL2, which will be here, because it has to decrement y again to get back to the next character. This is all kind of ugly because, see, if I do it this way, I'm going to have to take this pointer and put it here and here and here. And that does not really appeal to me. So I am beginning to consider using the 0 page locations, as I said. Okay, and so let's go ahead and do it that way. Let's go ahead and do it that way. So to do that, what I first want to do is get the 0 page locations I'm going to use, which are 50 and 51. So I will store those 0 page locations on the stack. All right. And then I will store the pointer to the string I'm trying to convert from C style to Pascal style in those locations that I just saved. All right, now this has to be y, now that we're going to do it this way. All right. All right, now it's the same thing as before. I have a pointer in the 0 page, and now I'm accessing the 0th character of the string pointed to by the address in locations 50 and 51. If it's equal to 0, I go down here. Otherwise, I increment y. And I branch back up here. Okay, now, opposite of what I did last time, when I moved that value from x to y, I need to move the value from y to x. All right, and I'll just, basically I'm just saving it in x. Because after I shift all the characters down 1 byte, I have to store it. Okay. Okay. So now I can do the same thing as before. I can load. Okay, I've decremented y. So when we come here at this point, after this right here, both y and x are indexing the null byte at the end of the string. I decrement y so it's at the character right before the null byte. okay? And then I load that character. I increment y, so now it's looking at the null byte again. And I store that, the last character before the null byte on top of the null byte. Then I decrement y. Again, as I said, if this now becomes 0 after this decrement here, that means it was 0 here also after this decrement. So we just got the 0th character and moved it to the first location. I mean, from the character in position 0 moved it to position 1, which means that we're done at this point. Okay, and so now all we need to do is y is 0, so we need to move that count of characters into A and store it in the 0th position of the string, which is right here. And all we have to do now is we have to get the old contents of these two 0-page locations and put them back. And when I do this, I always, you'll see I did it here too. I always push the high byte first, then the low byte. That's just how it's usually done on the 6502 because it's a little Indian processor, at least, yeah, it is. And then when I am going to put them back, I pull the low byte and store it, and then pull the high byte and store it. All right, so now I've used the 0-page pointer. So let's just go over this real quick and make sure it all seems good. Okay, so first I need to save the locations of the 0-page locations 50 hex and 51 hex. So I'll push the high byte, push the low byte. Now I store this pointer that I've been given x and y into those two locations, low byte, high byte. So now I have a pointer to a string in these two locations in 0-page. I load y to 0. I check the 0th character of that string. If it's a null, I go down here. That means I've reached the end of the string. Otherwise, I increment y and branch back up here. So y, as I scan through the string here, y will be counting the characters in the command line argument. At this point, when I do this, I transfer y to a and a to x. I'm just moving it from y to x just to save it because I have to remember this number, which is the count of characters in the string. I have to remember that until after I've moved everything down. I should point out, though, if I have a null string with the y, where y is 0 here, I should go ahead and exit. I don't need to, right? I'll go ahead and move y to a and a to x. I can do that. But now if this is 0, I'll go ahead and exit because exit means here. Right? Because at this point, if I've here and y is 0, I move y to a and move a to x. If the string is 0 characters long, it's just a null byte, right? Oh, I can actually directly exit because that null byte means 0 characters in the string. So actually, I don't even need to go here. I can just go. I don't need to do this. Not that it really matters, but. Okay. So basically, if a and x and y are all 0 at this point, I could go down here and just go ahead and restore those 0-page locations and return, because the string, from a C point of view, it's just a null byte. From a Pascal point of view, it's a byte in which the character count is 0. So it all looks good. But of course, if it's not 0, which it's generally not going to be, I think probably will never be 0, then we now have to start moving the characters down. So y has the count of characters. I'm going to decrement that once because when y has the count of characters in it, it's indexing the null byte at the end of the string. If I decrement it once, it's indexing the byte before the null byte, the character before the null byte. I would get that character. I'll increment y, so it's now pointing at the null byte again. I'll store it there. Then I'll decrement y to get it back to where it was where it got this one here. And if it's not 0, if it is 0, I'm done because I just moved the 0th byte to the 0th position to the first position. If it's not 0, I'll go up and do some more. I have to hit decrement again so that I go back to the previous byte. Okay, and when it's all done, remember I stored the count of characters in X. I'll move that back to A and store it now at the beginning of the string because Y is 0. And now my C string is a Pascal string. I will restore the 0 page locations I used and exit. So fix CL. Well, that was unexpected. You know, I wasn't thinking I would have to do that. So it just came up on the fly. So what I'm going to have to do now is up here, like right here before I open. Okay, so I'm getting, yeah, I've now put the pointer to the string in F pointer. So I need to get that pointer to the string in X and Y. JSR to fix CL. Okay. That will change the string from a C style string to a Pascal style string. Then I can try to open it here, and hopefully that'll work. Now, there is still one little issue here. Now that I've done that, my puts doesn't work to print it out. If I try to print out the string like this, it won't work, right? Because I'll basically run off the end of the string. That's actually super annoying because puts is expecting a C style string, and I've just changed it to a Pascal style string. Okay, what I'll probably do is change it back. That's just what I'm thinking. If I have to print out the name of the error message, the name of the file, I'll just change it back to a C style string. Well, for now, I'm going to save, exit, assemble, and try. And the worst that can happen is I screw up something and have to reboot the computer, but that's not a disaster, is it? Yeah, see, can't open file, blah, 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 blah. And it printed out nonsense, as you'd expect. Okay? But it's still giving me that same error that the path name is invalid. So I'm going to have to do more debugging here. So I'm calling fixCL with the pointer. I think what I'd better do is at this point oh, you know what? I think I'm just a dumbass again. I'm loading the wrong thing here. I need to load the pointer which is stored here, not the address of this thing itself. Okay. Okay. Good. Now it seems to be working, and the reason that I have here AS0, AS9 is because, as I said, I'm trying to use my puts subroutine, which expects a null terminated string on these things which are not null terminated. So I have fixCL. I'm going to change fixCL to let's say P2C stir. P2C stir. Or actually, it's C2P stir. C2P stir. C to Pascal string. Okay, C2P stir. C2P stir 0. C2P stir 1. I know this kind of thing is just boring, right? Maybe it's all boring. Stir 1. But in this case, I ran into something I just was totally not even expecting. I mean, of course, I should have been expecting it, but okay, C2P stir 2. Why? Actually, why do I have that? Okay, that's copying that down there. I guess I don't really need this. That could be 2. Oh, okay, now I'm dumb. I did need it. Okay, good. So let's just run it the same way. Assemble and run. Okay, same thing. Okay. Now P2C stir. All right. So basically, I want to do the same sort of thing. And so let me again use the 0 page location. Okay, so save the 0 page locations, put my pointer in there, and okay, get the count. Now I have a Pascal string, I'm changing to a C string, get the count, and store that in, put that in, well, need to put a 0 there to get the count. I'll put that in X and put that in Y. Okay, what I want to do now is sort of move everything back one. Like I was moving it last time in one direction, now I want to move it in the other direction. Let's see. Maybe I'll just yeah, I have an idea. Okay. So here I'm just getting the count. That's all I'm doing there. I'm getting the count of characters in the string. this will be a different situation here, where I need to increment y. This is, so I'm now looking past the count, I'm looking at the first actual character of the string. I get that. I decrement y. So I store this on top of the count, right? So when I come in here, y is 0, I increment to the first character past the count, I decrement y and storing this on top of the count. Now I'm going to increment y again. And so y is the same as it was after this increment. And if this was the last character in the string, then I'm done. So I will compare y to a 0, but it's not really going to be 0. It's really going to be p2c stir, let's just say 2 for the time being. And actually I don't want this here, I'm just going to go ahead and store that in p2c stir 2 plus 1. So I'm going to take the count and store it here. If y is equal to this count, okay, that means that the character that I just grabbed here and then moved back 1 is the same, is the last character in the string. Okay, so if it's not, then I'll go back to p2c stir 1. Okay. Okay. So let me just think for a second. If I have, for example, a Pascal string which is 2 characters long, then the first byte will be a 2. Then the next byte would be, for example, AB. Okay, so I'm going to get that 2 here. I'm going to store it right here. I'm going to increment to 1, get the character in position 1 and move it to 0. Then increment this back to 1. All right, then increment this to 2. Get the character position 2 and move it to character to position 1, then increment this back to 2. When I compare that to 2, yes, it is equal to 2, so I'm done. And y is now pointing where I want to put my null byte. So I'll load 0, and I'll store that in there. So that'll put the null byte in the correct place. That should be all good. Okay. Remember, this is not really a 0, it's whatever gets stored right here. Okay. Now I just have to restore my 0-page locations. And return. Whoops. Okay, I hope that makes sense. So p2c stir. So what I'm going to do now is after I successfully open the file, so, all right, so what I'm doing is I'm getting a pointer to the string. That's what this does. It puts it in F pointer. This loads it from F pointer and changes it to a Pascal string. Then I open it. Okay. And then if it successfully opens it, it goes down here to main 1. If it doesn't, it prints out this error message. I think what I'm going to do here instead is I'm going to go ahead and push the processor status flag, pull the processor status flag, and in between those two things, I'm going to change it back to a C string. C2C stir. All right. So after I try to open the file, I push the processor status flag, and actually I'm going to go ahead and push A as well, because A has an error code in it, if there's an error code. I mean, I don't actually think I'm going to prompt the error code generally, but just for the time being, I might want to see it. I will change that command line argument from a Pascal string back to a C string, and that way I can print it out correctly. And a lot of this, I mean, changing it back to a C string is probably not going to be necessary later. It's really just for my debugging purposes now, because I want to print out, well, I guess it would maybe always be necessary if I'm going to print an error message to say I can't open this file. But assuming the file is opened successfully, I won't have to do it, because I don't care really about the name of the file. Well, maybe maybe I do. Maybe I want to print out an error message like, you have an error in file, blah, blah, blah. So maybe I'll just keep it that way. I just change it back to a C string, and that way I can print it out. I just really want to use C strings everywhere and not Pascal strings. I just have to deal with that because it's ProDOS's little problem, which means probably I should go back and put it in the file IO stuff. I should do it all there so that this code doesn't have to see it. In fact, I'll probably do that next time. All right. Let's try it. Okay, now it prints them out correctly. It looks like everything's good. And I was hoping to get a little bit further than this today, but I think it's the right time to stop. So what we have done now is we have looked at the command line arguments. We've opened each file in turn and then closed each file. We haven't read it out of the file yet, but that will be next time. But what I will actually do next time before I read out of the files, I'm going to go back and take this code that changes the string from a C style string to a Pascal style string. I'm going to put that back in the ProDOS file IO interface, because yeah, I shouldn't have to deal with that junk out here. That's only to deal with ProDOS, the Apple II's disk operating system, and I want all that stuff to be in the ProDOS file interface code, not in my main code. So next time, the first thing I'll do is go move that stuff over there, and then I will come back and start trying to read from the file. All right, so see you next time.